Hello.
Hello. Hello.
This is code.org.
It's where we learn to write code.
These are blocks, and this is my workspace. The computer does whatever I tell it to do.
I learned to code with Elsa and Anna.
I learned to code using Star Wars.
I learned to code with Flappy Bird.
I learned to code with Minecraft.
Coding can be a piece of cake.
It can be exciting.
Yippee! It can be frustrating.
But when it works how I want it to work, it can be really rewarding. Then we learned about the BBC microbit. It is a small printed circuit board with many fitted components.
You should always handle it by its sides or edges to prevent damage.
The front has the LED display and A and B buttons.
The back contains key components like the processor, accelerometer, and micro USB connector. The silkscreen layer labels many of the important components. On the front is the display. The display is made up of a 5x5 LED matrix. Each pixel can display a single color of different shades of brightness. The two buttons, the A and B, on the front are the primary input devices. This means you program what you want these buttons to do, and when you push them down, it changes the image. They are known as the momentary switches, and they only stay on as long as you push them down.
The processor is like the brain and the microbit, and it's labeled on the silkscreen layer. It's the tiny plastic layer on the back, and it's even smaller than your fingernail. For those of you concerned about the technical side, well, it's a Nordic NRF51822, which contains a single-core ARM Cortex-M0 running at 16 MHz with 16 kilobytes of random access memory and 256 kilobytes of non-volatile memory for program storage.
The next feature is the radio. This allows the microbit to communicate with other microbits or with other devices. It is not labeled on the silkscreen layer. Instead, it is built into the processor. It communicates by using Bluetooth Low Energy. There is no antenna, rather a copper track built into the circuit board itself, labeled BLE antenna.
There are two built-in sensors in the microbit. The first is the accelerometer. Even though it's really small, it's very clever. It knows exactly how the microbit is positioned in space at any given time. Just like your smartphone rotates the screen from portrait to landscape, the microbit's accelerometer works the same way. It can track the angle of the device in all three axes, sideways, backward, and forward, and up and down. The second sensor is the compass. It's also really small. It can detect magnetic north and point you in that direction. So if you are building a robot, the compass can help you navigate between points.
The microbit has room for expansion through input-output pins that are located on the bottom edge, but aren't really pins but strips of copper on both sides. They are labeled 0, 1, 2, 3V, G, and D. The first three are the major input-output pins. The fourth and fifth provide power and a ground connection to complete any circuit you build. The pins have a small hole at the top so you can quickly attach hardware like a crocodile clip.
The micro USB port is on the back in the middle of the top edge. There are two things it is used for: to provide power through the battery pack when it's not connected to a computer, and to let you connect the microbit to your computer to change the program and communicate data back and forth. It is very, very important to be careful and gentle when using the micro USB port, because if you damage it, you won't be able to use your microbit.
The last feature is the battery connector. The battery connector lets you connect the 3-volt battery pack to the microbit so you can power your project on the go, like for a portable or wearable project.
Makecode.com.
This is makecode.com. It's where I write and download the code for the microbit.
There are tutorials to help you.
There are also project ideas and how-tos, like a duct tape wallet.
I'm making an Arceus carton robot. I am painting my robot. I'm painting my robot's teeth. I put the mouth on my robot using a straw and glued the eyes on. Then I attach a servo to the back. After that, I attach the straw to the robot to make its mouth open and close. Next, I download code to the microbit. After that, I connect this clip to ground, this clip to 3, and this clip to 0. This is what it does.
Robot shark doo 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 doo. Robot shark doo 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 doo. Nyam nyam nyam.
I'm making a genie ball. I'm trying to make a case for my microbit and its battery pack. I have finished writing my code. Now I need to download it to my microbit. I put the battery and the microbit inside of its case. This is my finished product. This is the front and this is the back. This is it when it works. Our pillow is comfortable.
Our cat's cute.
Is Baby Yoda cute?
Do straws have 2 holes?
I'm making a frustration game. First, I'm gonna take the styrofoam pieces to the box. Then I bent the wire. Next, I added the electrical tape to the wire and added the wand. Now I'm going to download my code to my microbit. This end attaches to the ground pin. Next, I have to connect these 2 clips to the audio cord. This is what it does.
I got 10.
I'm making a fruit piano. I'm decorating my fruit piano. To make it work, first I have to download the code. I connect this clip to pin 0 and this clip to ground to hear the sound my piano makes. I have to hold this clip that is connected to pin 0 so when I touch the fruit, it closes the circuit and produces sound. I connect pin 1 to the orange and pin 2 to the pear. This piano plays tunes. This piano plays songs.
It's my turn to play the piano.
I also made a birthday card.
And I made a step counter. I took 41 steps.
And I made a reaction game.
Then I made a thermometer.
To convert Celsius to Fahrenheit, 1.8 times degrees Celsius plus 32 equals degrees Fahrenheit. So 1.8 times 23 degrees Celsius plus 32 equals 73 degrees Fahrenheit. What will you create?
What will you invent?
Have we inspired you?
We believe in you.
Get coding!